Have you ever stopped to think about what happens when you click buy online? I mean, how do a dozen different things all happen at once without the entire system just collapsing? How do all these separate parts of our digital world actually talk to each other? Well, that's exactly what we're going to dive into today. The hidden but absolutely critical world of architectural messaging patterns.
Seriously, just picture it. It's a huge online sale, and a website gets slammed with a million orders. For every single one of those orders, it has to update inventory, process a payment, send a confirmation email, and schedule shipping. All at the same time. How in the world does it handle that kind of pressure without just, falling over? The answer isn't magic. It's really, really smart architecture.
And this is exactly why this stuff matters so much. This is not just some nerdy technical detail. Deciding how the different pieces of an application communicate is one of the most fundamental choices you'll make. And if you get it wrong, you're in for a world of pain. You end up with a system that's slow, incredibly fragile, and where crucial information like your customer's order can literally just get lost forever. So to really get our heads around this, let's use an analogy. I want you to think of your entire application, all its different services, as a massive, bustling city. The messaging system is the city's central post office. It's this incredibly organized system for sorting and delivering millions of messages, making absolutely sure every single piece of information gets to the right place at the right time.
Okay, our first stop inside this digital post office is what we can call the newsletter service. The technical term for it is publish/subscribe, or just pub/sub for short. And you know what? It works exactly like it sounds. One part of your system publishes an update, kind of like sending out a newsletter saying, hey, a new product was just added, and any other part of the system that cares about that news can subscribe to that newsletter to get the update.
Now, the really brilliant thing about this is how beautifully decoupled everything is. The service sending the message, the producer, it just shouts its news into a central channel we call a topic. It has no idea who's listening, it doesn't need to know, and frankly, it doesn't care. The topic itself handles the broadcast, and all the subscribers, maybe it's the inventory service, the search index, the marketing team, they all get the message and can do their own thing with it. None of them are tied to each other. It's incredibly flexible. And because it's so flexible, you see this pattern everywhere. It's absolutely perfect for sending out real-time notifications, for kicking off a whole bunch of different data processing jobs in parallel, or for feeding a constant stream of events into your analytics and auditing systems. It really is the workhorse of any modern event-driven architecture. Building on that idea, we have the fan-out pattern. This is like the main mail sorting room of our post office. This is where a single incoming package, or a single message, gets sorted and then sent out to trigger many, many different actions. So for example, one single order-placed event could kick off the shipping process, the billing process, and the inventory update all at the same time. Now, it's actually really helpful to think of fan-out in two different ways. First, you've got logical fan-out. That's where one event triggers different jobs in different services. But then you also have infrastructure fan-out, and that's all about raw speed. It's about making tons of copies of the same worker to chew through a massive flood of similar tasks all at once. Okay, but what if you really need a reply back? What if you can't just shout into the void? Well, that's where our certified mail service comes in, the request-reply pattern. It's a two-way conversation, but, and this is key, it's asynchronous. Think of it like sending a text message instead of making a phone call. You send your request, but you don't have to just stay on the line waiting. You can go do other things, and the reply will show up when it's ready. And this is the really clever part, how it all stays coordinated. The requester sends a message with a unique tracking number. We call it a correlation ID. The responder picks it up, does whatever work it needs to do, and then sends a reply back to a completely separate queue, but it stamps it with that same original ID. That way, the requester can easily match the reply to the request it sent out, even if hours have passed in between. Pretty smart, right? You'll find yourself needing this pattern for more complex scenarios, like orchestrating a whole multi-step process that could take minutes, hours, or even days. Just think about booking a full travel itinerary. You need to book the flights, then the hotel, then the car rental. Each step needs a solid confirmation before you can even think about starting the next one.
All right, so we've seen the individual services in our digital post office. Now, for the fun part. Let's see how they all work together by following a single customer order on its asynchronous journey from start to finish.
Okay, here we go. The customer clicks buy. Immediately, a pub/sub event called Order Created is published. Using the fan-out pattern, both the inventory service and the notification service hear this and spring into action. At the same time, the orders service uses request reply to formally ask the payment service, hey, can you please charge this credit card? It needs that confirmation back. And what if the notification service gets totally overloaded with emails to send? No problem. Simple queues act like a buffer, like a shock absorber, holding on to those tasks so not a single one gets lost in the chaos.
So look, these patterns aren't just abstract, theoretical ideas. They are the actual blueprints for real, tangible services that are offered by all the major cloud providers. Let's pull back the curtain and see how these concepts map to the brand names you probably see every day. So you're probably noticing a theme here, right? Whether you're working on Amazon's AWS, Microsoft's Azure, or Google's GCP, they all offer tools that map directly onto these patterns. Sure, they might have slightly different names, SNS, EventBridge, Service Bus, Pub Sub, but at their core, they are all designed to solve the exact same fundamental problems of routing and buffering messages between services.
But, and this is a really big but, the devil is always in the details. The way each of these services handles things like message ordering or whether they guarantee a message is delivered at least once or exactly once, these things can be very different. These aren't just minor features, they are critical trade-offs that an architect has to weigh very, very carefully based on exactly what their application needs to do.
And that brings us to the highest level of thinking here, the architect's perspective. You see, designing a great message-based system isn't really about picking a specific technology off a list. It's about understanding and then deliberately making the right trade-offs for your situation.
This right here is one of the most classic trade-offs you'll ever face. Do you absolutely need to process transactions in the exact order they happened? Well, if so, you're prioritizing ordering, which almost always comes at the cost of speed. Or is it okay to process a million messages all at once, totally out of order, to get insane levels of scale? That's prioritizing throughput. There is no single right answer. It completely depends on the problem you're trying to solve.
And finally, let's talk about some common traps to watch out for. First, don't overcomplicate things with request reply if a simple pub sub will get the job done. Never ever just assume messages will arrive in order unless the system explicitly guarantees it. And please always have a plan for messages that fail. This is often called a dead letter queue. It's basically a mailbox for failed messages so you can go look at them later and figure out what went wrong. Don't just let them vanish into the ether.
So when you're thinking about all these patterns, I want you to remember this. We're not just throwing messages over a wall and hoping for the best. We are choreographing complex, resilient conversations between different parts of a system. Great architecture is what ensures those conversations are reliable, scalable, and can stand the test of time. It's all about designing communication that truly lasts.